Okay, so this is your subjective final exam review, or it's very similar to it. It's not exactly like it. I'm going to go over the problems, show you how to work them. I would like for you to take notes on them. And then what you're going to do is use those notes. After each question, I'll pause the video, and you'll use your notes to work the problems that are actually on your final exam review. Okay, so the first questions talk about contrapositive, converse, and inverse. On the back of the board, I have some things listed about conditional statements and what they are. And conditional statements are our if-then statements. We turn them into converse, inverse, and contrapositive. I'm going to start with the converse one. That's where we switch our hypothesis and conclusion. So we switch them. So instead of if two angles are congruent, then they are equal, we leave our if, we leave our then. Those things don't change. And we reorder everything else. So this was first, now it's going to become second. This was second, now it's going to become first. So our new statement is if, now we're going to look over here, they are equal, then two angles are congruent. Okay, then to write the inverse, we add the word not. So the order doesn't change, so we have if two angles are not congruent, then they are not equal. And then the contrapositive, we do both. We switch them and put the words not. So we get if they are not equal, then two angles are not congruent. Okay, so use this information to do the ones on your paper that resemble them. All right, so this one says on a number line, point A is located at 0. So if it tells you on a number line, that tells you you need to draw a number line. Point A is located at 0, so here's A at 0. Point C is located at 16. Oops, let me do that the other way, like so it'll match the other one. So point C is located at 16. Then it tells you point B is the midpoint of AC. So AC goes from 0 to 16. Point B is the midpoint, or it's in the middle. And the point in the middle between 0 and 16 is 16 minus 0 divided by 2, which is 16 divided by 2, which is 8. So B is 8. Then point D is the midpoint of BC. So here's point D, it's in the middle. And again, we find that point by doing the same thing. We take our endpoints and subtract them. 16 minus 8 divided by 2 is 8 divided by 2, which is 4. So 8 plus 4 is 12. So D is at 12. Now it asks us what's the length of AB. AB goes from 0 to 8, so the length is 8. BD goes from 8 to 12, so the length is 4. AB plus DC, AB is 8, plus DC is from 12 to 16, which is 4. 8 plus 4 is 12. And then AC minus BA, AC is 16, 0 to 16, minus BA is 8, equals 8. So use that information to work the similar problem on your paper. What is the slope of a line perpendicular and what is the slope of a line parallel? Parallel lines have same slopes. They're the same. So what we need to do is figure out what is the slope in this line. What's the slope here? The slope is our m in y equals mx plus b. So our slope is our 5. So m equals 5. The line is parallel. So the parallel slope is also 5 because they should be the same. Now perpendicular lines have opposite reciprocal slopes. Opposite reciprocal, which means we write it as a fraction. So again, our slope is y equals mx plus b. Our slope is 5. And when we write that as a fraction, we write it as 5 over 1. Then our opposite reciprocal means whatever our sign is here, the opposite is change the sign. That's what that tells us. So our perpendicular slope, if this one is positive 5 over 1, this one's going to be a negative. And then reciprocal tells us to flip our fraction. So whatever's on bottom now goes on top. Whatever's on top now goes on bottom. So the line perpendicular to this line would have a slope of negative 1/5. Complete the following and truth table and or truth table. And I'm not actually going to complete these for you. I want to have you think about something. If I tell you if you do the dishes, so we're going to let P equal dishes, and you clean your room, so we'll let Q equal room, then you can go to the game. So if you do the dishes and you clean your room, do you get to go to the game? If the answer is yes, then it's true. If you don't get to go to the game, then the answer is false. So what if you do the dishes but don't clean your room? According to this statement, should you be able to go to the game? What if you don't do the dishes and don't clean your room? Should you be able to go to the game? And what if you don't do your dishes or clean your room? You do neither one. Should you be able to go to the game? Then for the or truth table, it would be dishes or room. So if you clean your room or you do the dishes, then you can go to the game. So again, here's our dishes. Here's our room. So if I tell you if you do dishes or clean your room, you can go to the game. Well, what would happen if you did the dishes and cleaned your room? If you did both, would you be able to go to the game? Did you meet my expectations? What if you do the dishes but don't clean your room? Should you be able to go to the game? What if you don't clean the dishes but you clean your room? Should you be able to go to the game? And what if you do neither? So use this to think about it and try to fill out your truth tables on your paper. Identify the relationship between the indicated angles. So angle 1 and angle 8. Those are outside. Here's our exterior, remember? Exterior. And then this middle part would be our interior. And then same side means they're on the same side of this transversal line. So you need to ask yourself, are they both exterior? Yes, they are. Are they both on the same side or are they on opposite sides? And these are on opposite sides, so that would be alternate exterior angles. Then if you look at, instead of 1 and 8, if you were to look at 3 and 6, again, are they both interior or are they both exterior? And they're both in the interior. Are they on the same side or are they on opposite sides? And they're on opposite sides. So these would be alternate interior angles. Then the last one we're going to look at would be our angle 1 and angle 5. So there's here and here. So are they both interior or are they both exterior? And the answer to that is no. One of them is exterior, one of them is interior. Are they both on the same side? Yes. So that means that they're corresponding. One's interior, one's exterior, and they're on the same side is our definition of corresponding. In the figure below, M is parallel to N and AB is parallel to BD. AC is parallel. I'm going to extend these lines because this is how we're used to looking at it, as our lines cut by a transversal. And it says angle 3 is 126 degrees. So then these angles right here, 7 and 3, are alternate interior, and our alternate interior angles are congruent. So if angle 3 is 126, then angle 7 is 126. Then if we turn it sideways and look at it as angle 3 and angle 1, those are on the same side, and one's interior, one's exterior, so those are corresponding, which means that angle 1 is 126. Angle 5 and angle 1 are again alternate interior, so that means that they're the same, so angle 5 is 126. Now, angle 3 and angle 2 are a linear pair, so they have to add up to 180 degrees. So if angle 3 is 126, then angle 2 must be 180 minus 126, which would be 54. So angle 2 is 54. 2 and 8 are alternate interior, so it's also 54. 8 and 6 are corresponding, so it's also 54. And 6 and 4 are alternate interior, so it's also 54. So remember, when you work these problems with our parallel lines and transversals, you're only going to end up with two different answers for each problem, because they're either congruent or they're supplementary. Those are our only choices. They're congruent or they're supplementary. And when you look at it, if they're congruent, then they look like they're the same angles. This angle does not look the same as this angle. This one looks to be acute. This one appears to be obtuse. So if you have an obtuse and an acute angle, then you know that whatever the angle measure of the one that looks like obtuse, all of the obtuse angles in that problem are going to be the same. So these are all my obtuse angles, and they're going to all be 126. My acute angles are 54, so all of my acute angles in this problem are going to be 54 degrees. In the figure to the right, answer question 11 and 12. These two angles are vertical angles, and vertical angles are congruent. So they're equal. So when we have a congruent, our formula is something equals something. So here we're going to have 4x equals 124. We solve the problem by getting rid of fractions and parentheses, which we don't have any. Combining like terms, there's none to combine. Separating, getting our x by itself. It already is, so our last step is to divide. So the 4's cancel, and x equals 124 divided by 4, which is 31. So the value of x is 31 degrees. Now these two are alternate interior, and those are also congruent. So our formula is going to be set up the same way. Something equals something. So here it's 2y equals 124. Again, we go through our steps. There's no fractions or parentheses. There's no terms to combine, and we're already separated. So all we have to do is divide. When we divide 124 by 2, we get 62. So y is 62 degrees. Use the graph paper to the right to answer the following three questions. So you're going to graph triangle ABC. Triangle ABC, A is at 2, 2. And it's kind of hard to graph these on this paper, 2, 2. And then B is 6, 5. And then C is 3, 9. So when we draw our line between those, we end up with triangle ABC. We rotate it 90 degrees, and when there's no clockwise or counterclockwise? We assume it's counterclockwise. So that's going to be rotating at 90 degrees that way. So it's going to end up over here in this quadrant. So what happens here is you can either use your patty paper to trace and then rotate, or you can remember that when you rotate 90 degrees counterclockwise, X and Y switch places, and the Y, which becomes the new X, changes signs. So you get negative YX instead of XY. So here we have 2, negative 2, so they're going to switch places, and this one is going to become negative. So we get negative 2, positive 2. So it goes right here. Then the 6 and the 5 are going to switch places, and the 5 becomes negative. So we get negative 5, 6, and then the 3 and the 9 are going to switch places, and the 9 is going to become negative. So you get negative 9, 3. Negative 9, 3. We draw our new lines. And this becomes A prime, B prime, C prime. So that's how it looks rotated. And again, you can do that with the patty paper, or you can do that by knowing what happens when you rotate 90 degrees. The last part asks you to find the length of AB, which is our distance formula. So we get x2 minus x1 squared plus y2 minus y1 squared. We're doing AB, so we're going to use 2, 2 for A. And B is 6, 5. We're going to label them x1, y1, x2, y2, and then plug them in. x2 is 6 minus x1 is 2 squared plus y2 is 5 minus y1 is 2 squared. And then you just simply plug those in. Plug that in straight to your calculator and get an answer. Alright, use the diagram to the left to find the following angle measures. Well, we might not be able to start straight away with angle 1, so we need to start with what we can start with. Angle 2 and angle 17 are a linear pair. They are supplementary, so they add up to 180. So 180 minus 117 gives me 63, so angle 2 is 63 degrees. Now angle 2 and angle 3 are vertical angles, so they're congruent. So if angle 2 is 63, then angle 3 must also be 63. So angle 3 is 63 degrees. Now, here we have two angles of a triangle, and we're missing one. We have a 47, a 63, and we're missing angle 1. So to find the missing angle, we add up the two angles. 47 plus 63 is 110. And we subtract from 180 because our triangle angles add up to 180. And we get 70. So angle 1 is 70 degrees. Same thing here. We have two angles, 53 and 63. We add those up and get 116. Subtract that from 180, and we end up getting 64 degrees. Alright, use the diagram to the right to answer the following three questions. Write an equation that can be used to solve for x. Well, we know this is what kind of an angle. It's a right angle, and a right angle has a measure of 90 degrees. So this part of my angle plus this part of my angle should add up to 90 degrees. So we should be able to write an equation that says something plus something equals 90. And our two somethings are going to be 6x plus 11 plus 3x minus 2 equals 90. That's our equation. Solve our equation for x. So we're going to get rid of fractions and parentheses, which we've already done. we're going to combine like terms. So 6x plus 3x is 9x. 11 minus 2 is 9 equals 90. Then we're going to separate, get our x's on one side and our numbers on the other. So we're going to subtract 9 from both sides. So this cancels. We get 9x equals 81. Divide by 9, x equals 9. Now it says find the value of each angle. And I do that by plugging my x into their equations. So 6 times 9 plus 11 is 54 plus 11, which is 65. And 3 times 9 minus 2 equals, 3 times 9 is 27, minus 2 is 25. And when we add these together, 65 plus 25, we should get our entire angle, which is 90 degrees. And 65 plus 25 does equal 90. All right, the last one says the following triangles are isosceles, and triangle ABC is congruent to triangle DEF. Now I've asked y'all to rewrite those as triangle ABC congruent to triangle DEF so that you can see what sides and angles match up. Now we know that the triangles are isosceles. This side is the same as this side, so I can put a 43 here because those are equal. Now I'm trying to find the value of Z. So Z is in EF. Here's our equation that has Z in it. So I need to find which segment in triangle ABC is the same as EF. And since E and F are the last ones, the ones that match up with that in this one would be BC. So BC is congruent to EF. We know BC is 43, EF is 7Z minus 6. When we have things that are congruent, our equation looks like something equals something. So our two somethings are 7Z, let me erase that, 7Z minus 6 equals 43. So I get rid of fractions and parentheses, which I don't have any. I combine like terms, I don't have any. And then I separate. I put my z's on one side, my numbers on the other side. So over here, I want to get rid of the 6, so I add 6 to both sides. I get 7z equals 49. Now that I'm separated, my next step is to divide by 7, both sides. 7's cancel, z equals 7, and that one is complete. That's the end of your review. By now you should have worked through all the problems on your paper. This is exactly what your final is going to look like. Just like you have a version on your test and I did a version on the board, there's going to be a third version that's going to be your final, but the questions are just the same. It's just different numbers, but the process for working them is exactly the same. I will post this video online. I will make a video for the actual review that you have in your hands, and I will post that video online. And then your exam on Thursday is going to be so similar that there is no excuse for you not making a very good grade on that exam.